Alrighty, folks. We're going to go ahead and get started. We're going to begin with just giving you some additional time to work on the activity from yesterday. If you are done, if your group has finished already, there's a couple of new features you can keep iterating on. You kind of have an MVP, but it's by far not the completely fully featured waitlist. So a couple of additional features you could consider making, again, only if you're done, is one, you could continue to update the UI to make it look nice. But in terms of new abilities, you could record when the reservation was made automatically and display it. Another one is that you could allow cancellations. So can someone call and say, hey, I want to cancel that? And then can we do that in the system? Does the system allow us to cancel things? And you don't have to worry about logging in and authorizing people. Just assume that this is managed like by the employees, and this is used by them to keep track of it. And then can you move people from the wait list into the reservation list? So I would say those are some good features to look at if you're already done. If you're not already done, then focus on still implementing the features you have. And it's okay. A lot of times you're going to be working with a different amount of it done. If you still are done with all of this, or you want to, you can work on iterating on the front end, making it look nice, maybe adding logos, doing some more of the styles in that as well. Kind of like you did for project one, where you can divide up the tasks on your group, build different branches depending on what you all want to do. So if you're still working on the hot restaurant app, you'll be in the same groups as last time, so you'll be able to continue working on it. We're only going to work on it for an hour. And then if you haven't already, make sure you can deploy. Make sure that you've deployed it to Heroku. So we're going to be opening up the breakout rooms. I'm going to go ahead and post this in class activities. We're going to give you another hour, essentially, to work on this. And adding in extra stuff. If you have questions, you'll be able to, we'll have the TAs cycle through, and I cycle through the breakout rooms to just check on how everyone's doing. After that, we're going to dive into MySQL and see how that can help us, especially we have a application that's kind of begging for persistence at some level. It doesn't really make sense that if the server shuts down, we should lose all of our reservations like it currently does. We're not asking you to do anything beyond that. In fact, that's another feature you could try and do, but it's not going to work when it's deployed because of the nature of Heroku and some other stuff like that. Cool. So what we're going to do is we're going to open up the breakout rooms at this point, and you're going to be able to continue working on Hot Restaurant. If you run into other issues, let us know. We're going to give you about 5 to 10 minutes, get reacquainted with the activity, get set back up to working on it, and then we'll be jumping into various breakout rooms to make sure that you're not stuck, or if you're doing some of the advanced features, that you have a direction to go based off of that. Cool. So we're going to go ahead and open up the breakout rooms. If you have questions along the way, we'd love to help you out. Good luck.
Zane, we are continuing to work on our projects from yesterday. I think we have an hour this morning to just finish it out and deploy it to Heroku. So I'm going to put you in your group from yesterday.
Cool. Thank you so much.
Mhm. Good morning. We are continuing to work on our hot restaurant apps from yesterday. We got it about an hour, so I'm going to put you in your groups. I think you were here, Walter, right? Like, I think you fell out.
I had to log off. I was having camera issues, so I had to restart everything.
No worries. Okay, there you go. DM made me come out of my breakout room.
I'm sorry, I'm like dying.
Just kidding. We're working on our projects from yesterday.
Okay,
you got like an hour.
Oh, perfect. Okay, thank God.
Okay, I'm gonna put you in there right now.
Thank you. I love you.
Oh, I love you too.
All right, folks. So the solved version that is going to be pushed up in just a second breaks things up into a lot of different sections. In fact, I think it does it as a little bit of overkill at the moment. So I'm going to be kind of replacing the back end a little bit with what they do here with our own, and then we'll just be referencing the rest of it. So I'm going to make a new file. I'm going to call this, well, actually, let's make sure we've got everything we need. We're going to make sure we have npm init-y, and then we're going to install Express as well. Now, I'm going to just copy over the public folder, which has our HTML in it, into the unsolved version because I think that's pretty much fine as is. And now we're just going to work on our server, as that's the main thing we're working with at this point. So looking at our UI, if we look at the Heroku app, we see that we're going to need routes for the main page, the view tables page, and the make reservation page. So we've got 3 pages, which means 3 HTML routes. On those pages, what happens? Well, on the hot restaurant page, you can pretty much just get to one of the other 2 pages. On the view tables page, we're going to need to pull data. So we know that we've got an API route that's going to get the data to show on the page. So get API current reservations. And then we might also have another one for the waiting list. And then on make reservation, we'll need a post request to send that. So another 3 routes. So let's go ahead and start off our web server right here at the beginning. I'm going to just do the standard boilerplate that you would pretty much use for everything. Let me make sure I've got my notes set up here properly. Just because I always forget how to write the middleware and look it up again and again. Const app equals express. Const port equals process.env.port or 3000, 8080, whatever port number you want to use. Generally, if it's above 3000, it's fair game. Though we'll be looking at some specific ones. Next, I want to tell it to listen. App.listen on port, and we'll just say console.log. Listening on port plus the port. Cool. So this is our web server. And then we can start talking about our HTML routes. So we would say app.get/ function recres. And we would do that for tables. And for our reservation, we could call it reserve or whatever we want. It's up to us. A lot of times people like to make a match with the HTML documents, and then / is often home or something like that. So these are our HTML routes. Next, we're going to need to make some API routes. These are going to be our data routes, and they're not going to return files. They're going to return JSON data. And they all start with /API for that reason. So /API / and then what did we label them? I want to be consistent with my front end that I copied over. Tables. wait list, and for get, and then I'll need another one that's a post to API tables. So these are all my routes, and I did that by kind of looking at what I need to do. I need to serve these files. Some of them have static content. This is how I can break apart different pieces of data, and this is my list of tables. In fact, let's go ahead and make some variables. Const, let's use let actually. Let tables equal array, let wait list equals array, and we're going to manipulate these in our API section. We're either going to add content to them, or we are going to retrieve the content in them. So let's start out with these app.get ones. They're pretty easy to do. I'm going to go ahead and add path as a requirement. It's a built-in module, and that's just to help us return back the correct thing. So I'm going to say, all right, res.send file path.join __ dir name, and then I'm going to move up into the public folder. So let's see. Oh, no, that should just be single one / public / table.html, because these are at the same level. If this was a folder down or in a different place, I would still need to provide the relative path to it.
Eric, question.
Mm-hmm.
Hey, can you please explain again what the path module does?
For this, it's just making the path to this piece on the hard drive, and so that it can find where to find this file in the piece we're working with. So this one is the file that this module is in, and then this says, and then go look from here, go over to the public folder and look for home.html, for example, or tables.html, etc. So it's just a way of building the path, or the file path. And we'll do that for each one of these. Tables and reserve.html. So at this point, this is just to serve each one of these. We'll take a look at them in the future in more depth, but for now, it's good to notice, hey, on home.html, no JavaScript. So it's not going to interact with our API at all. On tables.html, we've got some JavaScript. And if we look through it, we can see that we go to API tables. We also go to API waitlist to retrieve those pieces of information. And if we look on reserve.html, we can see that we connect to API tables and we send this new reservation data. So let's work on these other backend routes first. So I know if I need to save table information, I've thought about it. We looked at the 4 fields that we made earlier. So I know I'm going to need to store the name, phone number, email, and a unique ID. No, I'm going to need to store 4 of these. For this assignment, we didn't ask you to enforce any uniqueness between these. We're just going to assume that they work correctly. So for API tables, this is a pretty simple one. We're just going to send back the array of our tables. For waitlist, it's similarly relatively straightforward. It gets a little bit more complicated with API/tables when someone sends us information. So we know that they're going to have those 4 pieces of information. And we're just going to say, hey, front end, whatever you give me as the body of the request, I'm going to put into my tables. So I'm going to say tables, or if I say tables.push, rec.body, and then res.json true, this would say, hey, you got a reservation. However, we're limited to 5. So it should only let us do this if there's less than 5 people already occupying a table. So we're going to say if tables.length is less than 5, then we'll allow that to happen. If not, then we are going to say, well, you can wait on the wait list. Let me make sure I spelled that correctly. Waitlist dot push rec dot body, and then we'll say, hey, you didn't make it onto the list. Cool. So that's our API, and that stores all of our different pieces of information. And so now if I visit localhost 8080, my application should work. Now, we haven't discussed the front end at all yet, and we're going to talk about that next. But we only have 5 tables. If we look at the tables, there's currently none there. Let's make a reservation. Eric, or all of that. Email asdf@asdf.com and some unique ID. Submit. Yay, you're officially booked. If we go back and we look at the tables, doesn't seem to be working. Let me double check. Make sure I didn't mess anything up. So that's working. 0 is null. I forgot a very important piece, which is my middleware. I forgot the piece that says, let's make it so rec.body is populated by these pieces of middleware. Otherwise, I'm going to be stuck adding nothing. It's not going to wait until all the data from the post request has come in. So let's try that again. So let's make the reservation. We'll say Eric. My phone number is 123. My email is ASDF. My unique ID is ASDF. And let's submit it. I'm officially booked. Fantastic. So if I look at the API table link, that's what's being stored in there. And currently, nobody on the waiting list. So let's talk about how these two go back and forth. How is there communication between all of these? So with home.html, there isn't really any. It redirects us to some other pages, and that's about it. If we look at tables.html, or let's actually start with the reservation, because that'll make it a little bit simpler. So we start out here. The events that the user can do is that we pay attention to is when they click the submit button. That triggers everything else. In fact, let's go ahead and put this over on this side. So what happens when the user does that? Well, first of all, we don't want them submitting the form, but then we build this object called new reservation. New reservation has a customer name, a phone number, a customer email, and a customer ID, and those are just the results of grabbing those values from the 4 input fields that we saw earlier, wherever I put that.
I think you accidentally closed it.
Yeah, let's go ahead and bring that up real quick. Localhost 8080. So we're on here making a reservation. So there's my first ID field, there's my second ID field, my email, my unique ID, etc. So when I click submit, let's actually open up the network at here, and we're going to move this to the side so we can kind of see what the network's doing. So I'm going to click submit. It says, yay, you're officially booked. So if I look at my tables, I can see what I sent. Let's go ahead and get rid of the console for right now. Oh, and it refreshed the page. So let's click on preserve log and do it again. Click submit. Yay, I'm officially booked. And it should be on there because that should be an XHR request. There it is. For whatever reason, it was taking time. So there was this post request, and I sent to it a JSON object with these 4 fields. What I got back was just something that said true. So let's track that. So let's open up, let's close this or move this one over here for now. We're not going to use it. And let's chart what happens. So our browser arrives on the reserve page, or our browser has reserve up in the URL. From there, so that's this HTML route. We then send the browser this whole HTML document. The user fiddles around with it for a while, and then they click the submit button. Once that happens, we go and we find those input fields that we just looked at. We grab their info out of them. We even put a console.log to make sure that we've got everything correctly. And now we need to send this information to the server, which is what we're doing here. So this one doesn't use .then, instead it uses a callback. Either one is fine. You could have also written it and it would work just the same. So we call API tables, and we need to call it with some data. We need to make sure we have the middleware so we can use it. And so what happens? We send this new reservation, and this new reservation appears on this as the body of the request. So when the server receives this request, it says, do I have any route handlers that handle a post request with the URL /API/tables? Do I have anything that matches that? It checks this first one and says, does it match? No, 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 all the way until we get to the end here. And it says, oh, I have a route that matches that. I'm going to use that. All right, I'm going to hand this off to you. Here's the request as we've got so far, and here's the response if you need to use it. I'll be sending that response object back. So we say, first of all, we need to know how many people are in our tables array already. And starts out with 0. So we go ahead and we add all of that information, this object right here. And it's a copy of that object. It's not a literal, not literally that object. It's just a copy of it. And then we send back, hey, you made it. You're on the wait list. That appears right here as this data. This data is whatever we send back as the response, either res.json true or res.json false, depending on which branch we went down. So if that was true, if we had room in our wait list, we're going to tell the user, hey, you're officially booked. If the table is not available, we tell the user they're on the waiting list. That's the situation if it returned false. And then we just clear out our form. So it starts, if we were to draw it, we start with reserve, and reserve just loads this page in general. The user interacts with this page in their browser. Then when they click the submit, the browser makes a submit request, which gets routed to this function, to this handler. This handler then sends back one of these 2 responses, depending on the state of the server, which is the data right here. And then we proceed with the rest of it. So that's us clicking on the link all the way to us processing the information and sending it back. So the other ones are not too dissimilar, except they don't have to worry about sending information to the page. That's why they're GET requests. So if we look at tables.html, let's sort of condense some of these requests. So we've got two functions to help us out: run table query and run waitlist query. And we call those right at the beginning. One of these is going to call /API tables with get. The other one is going to call API waitlist with get, and they're going to go on simultaneously. So let's start out with /API/tables. With /API/tables, this is after we have appeared on the tables page, we load in tables.html. Immediately, the browser says, I'm going to run table query and run waitlist query. So run table query issues a request that is handled by this one, and run waitlist is run by this one. But remember, it's JavaScript. We can only do one at a time. So whichever request get theirs first will run. Let's assume it's run table query. Run table query is just going to get back that data that we have been including from our post request. Starts out empty, and then eventually we add in those objects with all of those different pieces of data. So we'll go ahead and erase this one for now. So we open this up, and this table data is this tables that we got right here. It's that array of objects, or it's a copy of it, more accurately. And so we come down and we say console.log table. We go through each one of the items in that array, and then we build a item based off of that and append it to the list. Pretty much the exact same thing for the waitlist. The only difference is that we're going to be getting different data. Instead of being called from API tables, we're going to get the waitlist array. But other than that, pretty much the exact same. And that's the interplay between the two of these. The server stores all of this data, and it can receive this from any client at any time. So it's responsible for holding on to this data after everyone has made all of their requests and sending it back. These pages, as soon as they arrive, they say either I need to pull the data that's on the server so that I'm up to date with whatever's been happening with the server, or I'm sending data to the server so that it can keep up with all the different things that the user wants to do. Cool. Questions?
Is there, what's going to be most typical? Is the JavaScript being inline in the HTML, or it being like in an index.js?
It's going to be most often in a separate file, but we're doing this because we didn't want to make a reserve.js route, which we would have to make for each one of these, or a style.cs, a reserve style.css file, because we can want to really introduce this structure to you. Now, we could do something like that. I'll do it with just this file for now, but let's say I wanted this file is getting kind of big, and I really want the focus of the HTML to just be here. So I'm going to make a new file, and I'll call it reserve.js. Take off the script tags. And inside of reserve.html, where that was, let's start out by trying to load it. Source equals, let's say, reserve.js. Cool. So let's refresh the page. on reserve.js, let's click on this section where we're trying to load it, and you can see that I get a 404. Huh, that seems a little bit odd until we realize, let's go look at our routes. Does this match reserve.js? No. Does this match reserve.js? No. None of these match reserve.js. Now I could say, hey, go ahead and send back this file like that. And now it will work because now I have something that matches up with it, where I built another one, but a lot of times it's easier to just write that inline. Now, as you might notice, all of the stuff in our public folder, whenever anyone asks for it, we just want to send it. We don't want to care. So rather than building out a route like this over and over again for each one of the files, what we want to say is, hey, if you get a request and it just matches one of the files in the public folder, just send it to them. Just send it to them. Very common scenario. We have a lot of static files. There's going to be a lot of CSS, a lot of images potentially. In fact, let's go ahead and start sorting this a little bit better. So let's make a new folder. Let's call it JavaScript. Let's move reserve.js into it. If we wanted to update our route here, we would have to then say /js/reserve.js, and then here we would say /js/reserve.js. We'd want to sort of mimic that structure. But we don't want to have to do this for each one along the way. I don't want to have to then make a route for home.js or home.style or something like that. So instead, I'm going to comment this out and I'm going to say, hey, another piece of middleware, but app.use express.static. These are just static files, things that aren't necessarily going to change very much. And what am I going to do? I'm going to tell it what folder to route everything to. So now, when I get a request, the first thing I'm going to do is I'm going to look in my public folder. So I look for /js/reserve.js, and I say, hey, public folder, do you have a file here at /js/reserve.js? And it will go, I do. And then it goes, great. Now that will still happen for everything. If I call /API/tables, it'll check here first too. Fortunately, that doesn't happen to match anything in there. But this will enable us to just do any generic file. So you can use express.static to handle that if you want to. In fact, I think in the more broken apart solution, they use that as well. No, they don't. So one last thing I want to comment on this solution. You'll notice that we actually broke our HTML routes and our API routes into separate files. And so what we did is we made a function that we could pass the app into, so that then we could say, hey, let's add /API/tables. Let's can add /API/waitlist. And this allows us to break up these different sections. You'll also notice there's an extra clear method here, and what it does is it changes the length to 0. If you set the length to 0, think of it like you're smushing the array down and all the stuff that wasn't there just kind of falls out. That's one way of doing it. You could also reset the array to just be equal to square brackets if you wanted. So inside of our server, we get that function back from API routes, and then we just pass the app function to it. So our server is got a little bit less set up there. So this is one way of building routers or based off of our routes. Cool. The next thing I want to do is, ideally at this point, you've already followed the supplemental instructions for having your database server set up. Before lunch, I want to show you how we can validate that works. If it doesn't validate, you can try going through the instructions again over lunch, and we'll have some time after lunch to make sure that to verify that, but I want to just do it. It's a relatively simple process. Remember, you need to have installed 2 programs, the MySQL server and the MySQL workbench. The MySQL server is kind of like our web server, and in that it's hidden, it's behind the scenes. We're not going to see a window pop up that represents it. And then MySQL Workbench is like our browser. It's how we as people are going to look at the data inside the server. To use an analogy, it's a little bit of a strained analogy, but it works. So we're going to open up MySQL Workbench. Yours might be slightly different than mine, but it's going to be the same general idea. So if you land on this home page, or you can make a new connection if you want to on here. So you can say database, connect to database. Either one of those is fine. I'm going to click the little plus icon right here. What this is going to do is pop open this. And it's going to ask me, hey, do you want to connect to your SQL database? And so I'm going to name this connection something. You could name it my connection. The host name, 127.0.0.1. That's sort of the numerical way of saying local host. It's just a number that means local host. And the port by default is 3306. If you just used all the normal, as you followed the instructions, then it should be on port 3306. Next, I'm going to click test connection. It's going to ask me for my password. Your username should be root. And I'm going to put in my password, which I've labeled DB password. I'm going to save the password in the keychain just so that I don't need to keep doing this again. Click OK. I successfully made a SQL connection. I'm going to click OK. I'm going to click on my connection that I just made. And these are all the databases I have. You're not going to have all of these. I have plenty of these that I've created. One that you should see on here, though, is SYS for system. You should have that database there if you connected correctly. So that's how you do it. If you run into issues, let us know. We're going to give you 10 minutes just to in your groups just to verify that's happening. Try troubleshooting in your groups if you're running into any issues. If you haven't followed the instructions yet, you can click on the supplemental section, and they have one for Mac. They have one for Windows. You can just press Control-Shift-V on it, and you'll get the nice pictures so that you can see what everything looks like as you go through trying to install everything. If you've already gone through those guides, great. You can begin looking at some of the SQL that we're going to cover. I'm going to post a link in class activities for you to read more if you're already done at this point. Cool. So I'm going to post all of these in class activities. We're going to open up the breakout rooms. Let us know if you run into issues. We're just going to use this time either to make sure that we're set up or that you can start reading ahead on SQL, which we'll start talking about after lunch. Good luck. Alrighty, folks, welcome back from lunch. We left off where we were going to talk a little bit about MySQL. MySQL is we're going to be kind of just jumping in immediately, but MySQL is our first introduction to databases and persistence and keeping things around longer than the life of a program. We can do this with files if we want to, but files are often pretty slow and aren't necessarily really great at this kind of task, especially when we start working with really structured data. We'll see later how we can use object-like structures and when we use MongoDB, and we'll still be interacting with the database in a very using objects in a lot of ways, but we want to look at how we can sort of talk about or how we can work with different aspects of MySQL. So let's talk a little bit about it. If you are having issues with the connection, you followed the instructions and you got stuck, you couldn't move forward, or you just were running into errors, go ahead and message the TAs while we're going through this, and we'll build a list so that we're able to troubleshoot any issues before going forward while we're talking about it. So let's start talking about MySQL. MySQL is a dialect, is what we call it, of SQL. SQL is sort of like a language family, you might say, and it stands for Structured Query Language. Other dialects that we're not going to cover in this class include things like Postgres. Microsoft has one called MS SQL, and there's plenty of others out there as well. They have a lot of overlap, but like dialects, they are slightly different from one another. So we're going to be working with this one primarily. So it's the nice thing about MySQL is that it's open source and it allows us to store things over time. Previously, if we had things that just lived as long as the web page. That was about as long as we could store stuff. Then we learned that we could store things as long as the server was running. Now we're going to actually make sure that we can store those things with the database. You could do that with a file, theoretically. In fact, SQLite is a scheme for doing that, where the database is pretty much just a file. But you tend to lose out a lot. You tend to have things be a lot slower. You tend to have things not work as quickly. So instead, what we have is a database program, or our database server. This is another program that is running on our machine. It's one of, like a server, we don't want to depend on it being on the exact same machine. In fact, when you deploy stuff to Heroku, they will be on different machines when you use MySQL servers. So your database server is a program that can accept requests and send responses, much like our web server. So our browser talks to our web server, which in turn talks to other servers, including things like the database server. Now, just like we can use, Chrome to talk to this directly, or we can use Postman to talk to the server pretty directly, we're going to be using the MySQL Workbench to talk to the database server directly. This is going to let us browse the data contained inside of it, which is pretty cool. Now, let's talk about the organization within the database server. So up at the top level, you've got the server. And within the server, you're going to have many different databases potentially. all the work we do in this class, you're going to just be working with a single database. But bigger programs, especially if you start talking to programs that interact with each other and do a lot of different things, might be connected to multiple databases. In our case, we're just, and throughout this course, we're just going to have one at a time. But you could potentially have multiples. You could even be connected to multiple database servers. Within each database, we have the next level of organization is tables. And these kind of look like an Excel spreadsheet or a Google spreadsheet in some sense, because they're built out of what we might think of as rows and columns. So it might be something like rows and columns. The next layer of organization would be our columns. So you might have things like, let's say that we're keeping track of people. You might have an ID, a first name, a last name, and a favorite food. And then each row would be filling in data about that. So we'll go ahead and say I'm 1, and I like pizza. Who wants to volunteer their favorite food?
Chicken parm.
All right. Likes chicken parm, etc., etc. So each one of our rows is going to fill out each one of the columns. Now, we might have a third entry where, let's say, anonymous person, and we don't necessarily know their favorite food. It's possible that you wouldn't fill out all the columns if this column is something that can be nullable. So sometimes you're going to have empty spaces in your data, especially in real life data. You're going to have places where it's like, oh, we actually just don't have that information. But we're going to try to as much as possible. So everyone has a value. Each one of these rows has a value for each one of these, even if that value is null. So we can continue thinking about tables kind of in this way of this column row structure. So tables are then broken into columns, and then our rows are when we fill out each of those fields or each one of those columns is how we would sort of set that up. So this we largely think of as our structure, these top 3 layers, in particular these 2. These are our structures. And normally, during the operation of the database, during the operation of our programs, these don't change. What we do is we do operations with rows. We might read the rows. We might add new rows. We might delete new rows. We might update new rows, but the program, the web server, isn't going to usually modify the structure. It's just going to do these 4 actions on our database. In fact, we've got an acronym for that, which is CRUD, which is create, read, update, and delete. So as we're thinking about these rows, we think about these different things. And we actually tie these to a lot of different things. We'll look at the SQL commands, but we can already sort of attach these to some of the HTTP verbs that we've learned already. Create, well, that's a post request. When we made new reservations, we posted that data. When we read new information, that's GET requests. We're not changing anything in the database, we're just getting the values back out. Delete, nicely enough, is named delete. I've mentioned that a little bit less. We'll look at that in more examples in the future. And update, well, that's put and patch. Put and patch both have to do with update, they just have to do with slightly different versions. Let's think about this. So if I said that, hey, we figure out for the anonymous person what their favorite food is, I might not need to include everything about that in the request. I might write for our anonymous person, if I wanted to send a patch request to say /API/person, I might just say, hey, here's the ID of the person, and their favorite food is hot dogs, let's say. So this is a patch because it doesn't include all the information about it. It's not complete. We're just finding something and sort of changing smaller pieces of it. Versus if this was a put request that we sent to /API/person, we would include all of the information about them. So we would include the fact that this, and then we would say first name, anonymous, and last name, person, like so. So this is starting to get into URLs and something called RESTful web services, which we'll talk about more in the future. You might have seen those in job listings, or as you go throughout the internet, you might have run across those. If you haven't, that's fine. We'll talk about them more. This, again, is a style
Frozen, Eric.
for writing complicated. Oh, am I back at this point? All right, where did I cut off?
You were saying style.
Okay, and just kind of cut in there. Yeah, so RESTful web services is a style of web programming. And so you've already kind of been learning some of the pieces along the way. We'll go into more detail about it. So even if you aren't familiar with it yet or haven't seen it, that's okay. We're going to sort of show you a style, a way of talking to web services, organizing things. Is it the only way you can do things? No. You could do deletes with get requests, for example, but it helps make everything make sense, which is definitely something we want the more complicated our programs get. If I can just look at the route and know exactly what it's doing, so much the better. Cool. So let's look at how we can actually create this structure. A lot of times we're going to be using the MySQL workbench to create this structure where we have all the database, the tables, and the columns. We even might seed a couple of different rows in there, and then our web server is going to just be operating on those rows. So we're going to have sort of a setup stage where we sort of set up our web server the way that we want. And then we're going to have an execution phase where our web server interacts with our database server. So we're going to spend a lot of time looking at the beginning at setting up the SQL server and working with that before we look at actually connecting our web server to it. So it's going to be a little bit before we're back there, but hopefully we'll connect it before too long. So the first thing that we need to do is we need to have a database. So I'm going to get rid of some of mine on my MySQL workbench just because we're going to be recreating some of them ourselves. It's almost like I've taught this class before. Let's go ahead and get rid of that particular database. When you delete a database, it's referred to as dropping a database. I like to picture that I have the database in my hands and whoop, slips out, and then poof, all the data scatters on the floor and is swept away by the wind. Your imagination might have other ideas about what that means. But let's go ahead and start out with just making one. We want to begin by making a database. If you want to follow along with all the SQL commands, we'll be going through each one of these within the animalsdb.sql file. So after you've connected to your database, like so, and I might be writing the commands out here to make them easier to read, but the first thing that you want to do is you want to make sure you have a query tab open. If you don't, you can go to File, New, Query tab, and it'll open one up for you. Next, we're going to issue a series of commands. And these are going to be setup. And because our database is persistent, we just need to run some of these commands once, and then it's done. The same way that you just need to write out to a file once, and then it's done. So we're going to start out by saying create database, and then the name of our database. We're going to call this one, if we look back here, animals underscore DB. Just want to be consistent about it. Create database, animals underscore DB. Now, SQL is case insensitive, meaning it'll operate whether I write create database or create database in terms of its commands. That said, we have a consistent casing structure we want to follow. If it's a SQL command, I'm going to write all of those in uppercase. You can tell if it's something that SQL is choosing for us. If it's all in uppercase, that means it's a SQL command. Things where I have choice over the name are going to be in lowercase, like animals underscore DB. So I chose the name animals underscore DB. It could have been what about a bing bong underscore DB. It doesn't even have to have the underscore DB. That's just a common convention. And so as we go throughout all of these exercises, and whenever we're programming in SQL, you can follow that convention to help you disambiguate, hey, is this something that is an arbitrarily chosen name, or is this something that's part of the MySQL language to help you out? So let me run this. I'm going to select the whole thing and click this lightning bolt. That will run whatever I have selected. If I don't have a selection, it'll run the whole query tab. So I run this and it says create database, 1 row is affected. And if I try and click it again, it's going to give me an error. I can't create the database animals DB. And if I look into the reason why, it'll tell me that the database already exists. So running the same command, unlike running a JavaScript program, because things stick around over time, I can't necessarily just run it immediately and then run it again because stuff sticks around. Now, over here on the left in all of my schemas, I don't see animals DB though. And that's because the MySQL Workbench hasn't checked in recently with the server to say, hey, what databases do you have? Fortunately, there's a little arrow right here, little spinny arrow next to schemas. It's very difficult to see, but it's on the same line as it. If you click on it, or you can just right click in that section and click refresh all. If you don't see schemas, there's administration and then schemas in this one tab over here. Make sure that you're clicked onto it. And then you can right click, refresh all, and now we see, hey, animals DB is there, that database I just created. Now, questions so far?
Do you have a colon or a semicolon at the end?
It's a semicolon.
Yeah, I went through some of them and I did see that a
'Cause
lot
it,
of it.
yeah, it rejected me for the colon, but then I did it without anything and it was fine.
Opened.
Right. It's best to have semicolons. MySQL in general is less forgiving than the JavaScript interpreter is. So it's going to yell at you quite a bit if you forget semicolons most of the time, especially between statements. If there's nothing after it, it's a little bit more forgiving, but it tends to be a lot more cantankerous is the way I like to describe it. Now, oftentimes, because we're potentially working on projects together, and just because I created a database on my computer doesn't mean that if I'm working with Michelle, Michelle has that same database on her computer. So what we often do is we share something called a schema file. And we often might name it something like schema.sql. And when we run this schema file, we can just copy paste the contents into the SQL Workbench and run it and not think about it too much. Now, right now, this is problematic because if I already have it and I run it again, I'll just get an error. So that's why before this, people will say drop database if exists animals underscore DB. What this does is it will delete the database if it already exists. And so people will often use this in development while they're first starting out with their SQL file. It'll get rid of the old one, which might not be current anymore, and then it will make a new one. So We run those two pieces, and I can now run this as many times as I want. It'll drop and re-add the database. Unfortunately, when I do that, the schemas lose track of it. So I'm going to right click on the side, click refresh all, and see it. And those are just the first two lines we see here. You'll also see we have comments, and unlike JavaScript, they don't start out with // but they start out with --. So --, drop the animals DB if it exists currently, is our comment for this command. Next, we're going to say use animals DB. I've got a lot of different databases here, and just because I created one just now doesn't mean that's the database I want to use. So I have to say use animals DB. That means that I am now making this the active database. If I go back to my diagram, it means I'm now sort of focused on things in this particular database. I'm not up here on the database server. I'm at a particular database, and I can make sure I'm not accidentally in the wrong one. It's a common error, especially when you're first starting out, to forget that line. You don't want to, because then you can start affecting databases other than the ones you intended. So use animals DB is that next line. If we look back in here, the next thing that we're going to do is we're going to create a table called people. And when we create a table, we also specify the columns that are in that table at the same time. So we include with it the name of the column, the data type of the column. We have to be a lot more strict about it with SQL than we do with JavaScript. So varchar 30 means a string with a max length of 30 characters. And this is mandatory, can't be null. Same thing with has pet. It's a Boolean value. It has to be Boolean. It'll be as true or false, and it's mandatory. Now, whether this person has a pet or not, we're sort of making a database for a pet store, and we've got potential customers. Some people have pets already, some don't. We've got the pet name here. It can also be 30 characters, but it's possible that someone doesn't have a pet yet. And so it's not mandatory. There's no not null. In fact, it can be null. Same thing with the pet age. The integer has to do with how many precision places it has. You can usually just leave this off with integers. You can't really leave it off with strings, but you can leave it off with integers. Most of the time, you're just going to see int or integer. Our examples will include a number after them most of the time. For anything that's not varchar, you can kind of ignore that most of the time. And decimal. I'll talk about it a little bit with decimal because that will help you control the number of decimal points or numbers you get after the decimal point. So if you're doing something with money, you don't want to have like 12 decimal points after it. Cool. So if I add this to my workbench, and let's run this whole thing again. It drops the database. It makes a new database called animals.db. And then inside of that animals.db, I can open it up and I can see what tables there are, and I can look at people. Now, people currently has no rows in it. We haven't added any data into it yet. So let's look at how we can do that. We're going to sort of start with our create from the create, read, update, delete section. And we do that with this insert into command. Insert into the name of the table, in this case people, the attributes that we want to insert into, and then the values of each one of those attributes. So we're going to insert Ahmed, the value true. Whether he has a pet named Rockington, that is 100. In fact, we can run that same command twice. Let's close that one. We can run that same command twice, and it will just make 2 of them. Let's go ahead and grab some of these other ones as well. We'll add in Jacob, we'll add in Peter, etc. So let's run the whole thing. It drops the database. Again, it runs all of it. Oh, I think I accidentally, copied in the word people where I shouldn't have. There we go. Drop the database, bring everything back. And now you can right click on the people table and click this top option, select rows, limit 1000. So it's going to say, give me the top 1000 rows. We have nowhere near 1000 rows, but it'll just give us the ones it has. So we can see all of our entries there on this little table beneath it. The name has pet, pet name, and pet age. You'll notice that to do that, we said select star from animalsdb.people. Since we're already using the people database, we don't necessarily need to specify that, but it can be helpful. So we could say use animalsdb above this, and then we could drop that. Now, what we have here, the star, is the asterisk symbol, and that just means all the columns. Select all the columns. If I just wanted whether their name and whether they have a pet, I could say name, comma, has underscore pet, and then it would only show those columns. This is our read operation. So it can say, oh, hey, here's Ahmed. A lot of times in the database, it'll represent true as 1 and 0 as false. So Ahmed has a pet. The other Ahmed has a pet. In fact, we entered 1 in here twice. Jacob has a pet and Peter does not. So let's go ahead and change it back to star. Any questions so far? All right. Next, if we're following our acronym, first we had create, now we've covered read. What's after that for CRUD?
Update.
Update, and then we'll look at delete afterwards as well. So update already has this one on here. So update people, we're going to say that Peter bought a pet. So we're going to update the people table. We're going to only change it where the name is Peter. And what are we going to do? We're going to set has pet equal to true, pet name equals Franklin, pet age equals 2. So we're going to copy this into here. So let's run this command specifically just by itself. And then if we run the select command again afterwards, I'm going to say select star from people. Then we can see that Peter now has a pet named Franklin, who is 2. So it's gone through and made updates to it. Now, if I forgot to include a where clause on here, if I just ended it here, what do you also would suspect would happen?
Would update the whole table.
Yeah. So each one of everyone now has a pet named Franklin. That is 2. Now, so when some of you run that command, you might have gotten something that says, hey, we don't allow you to do updates where you're not setting, where you don't have some restriction around it. You're going to have to turn that off in your editor. So MySQL Workbench, Preferences. We're going to go over to our SQL editor. We're going to scroll down all the way to the bottom under Other. There's this box that says Save Updates, where it rejects and deletes with no restrictions. Because of the nature of the exercises we're going to do, we're going to have you leave that box unchecked. Make sure it is not checked in this particular case. If it is, you're going to run into errors as we work on certain pieces. Now, is it a good practice to have this on afterwards? Yeah, It's good to always have restrictions around what you're updating, but for the purposes of this class, we're going to leave it unchecked. And that's just something that the MySQL Workbench program is doing to try and help us. It's not something that's built into SQL. It's something that this software tool is helping us do. Cool. So we were able to update people with each one of that. And now I might want to be like, oh, I want to get rid of some of this. I want to delete Ahmed, maybe in this case. I've got, oh, I wrote Ahmed in here twice. The problem is I don't have a way of uniquely identifying one row named Ahmed from another. So if I wanted to get rid of it, and I say delete from the name of the table, people, where name equals Ahmed, then I'm kind of in trouble. So let me go ahead and run this. And if I run my select star from people command again to read it and see what happened, I'll notice that I lost both entries here. So oftentimes what you're going to see here is that we're always going to give everything in the table a unique ID. That way we can always say this row is different from this one because it has some unique property to it, often called the ID. Now we don't want to have to worry about that when we're making new people. So we're going to go back to our SQL file that we were working with earlier that kind of told us about these different options, and we're going to add in an extra column. We're going to call that column ID, and it's going to be an integer. We're going to tell it to auto increment, and we're also going to give it the label of a primary key. Whenever other tables reference this, or whenever other people want to reference int rows in this table, they're primarily going to do that by referencing the ID column. Put a comma at the end because each one of our columns is separated. Let's run this thing again. So we're going to again insert Ahmed a couple of times into our database. So you can see here, we're inserting Ahmed both times, same way, no problem. I'm going to run this. And we made a new schema. I'm going to come down here and I'm going to say select star from people. I'm going to just select this one, hit the lightning bolt, and you can see that we've got Ahmed 1 and Ahmed 2. It automatically applied an ID variable for me. I didn't need to change anything else about it. So now when I come back here and I want to delete my duplicate Ahmed, I'm not going to say where name equals 1. I'm going to say where ID equals 2. So I can get rid of my extra entry. I run it, I select the people, and now we have that missing piece. Another fun thing to note, if I now say insert into people, let's go ahead and I'll add myself in there. So insert into people. And the next thing that we write, let's go back and grab the piece on here. Our list of columns that we want to insert into. So name, has pet, pet name, pet age. We're going to then add in these particular values. I'm going to say, all right, my name is Eric. I do have a pet, and true is a keyword, just like it is in JavaScript. It's here in SQL as well. The pet's name is Moses, and when I got him in 2017, he was 3, which means he's 6 at this point-ish. So now when I insert, I run this, and then if I select people again, we're going to see that I'm added into the database, and there's now no longer a row 2. We always move forward. There's no row 2 that we're going to go back and fill in later. There's just no longer a person with an ID of 2 in our database. Now, a lot of times in practicality, we don't delete data a lot of the times, especially like records with people. Instead, they'll be archived or marked as inactive. So a lot more of the time, you tend to update records to say, hey, this person isn't active anymore. Very rarely will companies actually say, yeah, we should delete a ton of data. They'll usually hold on to it in some manner or another. So sometimes you're not going to see delete as much as you're going to see the other 3. Create, read, and update. Now, it might look like a delete to the user, but oftentimes the companies will hold on to it just in case, or maybe for like 72 hours to be like, in case a customer calls and says, oh no, I deleted all of this stuff, they can restore it relatively easily, things like that. And oftentimes they've got other backup strategies and different things going on in place. So that's a lot. But let's map it back to the acronym we learned right here at the beginning with CRUD. And we learned kind of what HTTP verbs they worked with. Let's go ahead and push that off to the side for now. And we're going to think about this in terms of SQL commands. So let's actually it'd be easier to just start with this, and we'll do it in CRUD. SQL commands, and we'll start out with create, read, update, and delete. So for create, what was the SQL command we used there to make new rows in the database?
Create table.
Well, this is specifically talking about rows in the database.
Oh, insert.
Yep, we had insert into. Most of the time when we're talking about CRUD, we're talking about a structure that already exists. So we're talking about rows, but yes, insert into. If we wanted to get something out of a database, we wanted to read the information, what would we use?
Select from.
Yep, select from. If we want to update something, these ones are kind of gimmies.
Update.
Update, and then delete is delete. So those are a little bit easier to remember. But this is always what we're doing in terms of rows. If we're talking about our databases, you'll see that we use create database to make it, use database to use it, and drop database as well to get rid of it. There's also ways to alter the database. We're not going to get too much into that. In this course, but it's there, and once you're familiar with the other pieces, you can always just delete it and then reopen it again. Tables, very similar. Create table, and then we include the table schema, the different columns that it's going to have. Then we can also drop a table as well, where we can say, hey, I don't want to use this anymore, and the somewhat more used alter table. Again, we're not going to talk about that a ton in this class. Most of the time you can just drop and then make a new one rather than having to alter an existing one for this class. For columns, those are going to be created as part of the create table function. And you can also use alter table to either add or remove them. So the tables and the columns are very tightly wound together. And then the rows are the ones we just went through. Whew. That's a lot of stuff to have gone through at once, but that kind of gives you an overview of what stuff is going to look like in your database in terms of tables, in terms of rows, in terms of columns, all of the different pieces that work together. So now we're going to actually give you a chance to work with these. So you can If you want to just see some of the different things that we did, you can just copy and paste this whole thing into your SQL workbench. In a query tab, select the whole thing. You could do that using Command A, and then click the lightning bolt and it'll run through and do everything. If you want to see what it did, you can write select star from the name of the table, people, at the end, and then you'll be able to see on your machine the results of that. So that's kind of a way to look at that. We want you to use that as a basis and start making your own tables. So if you go ahead with me and open up O2 favorite DB no data, we're going to ask you, based off of what you saw with the people table, to create a new database with 3 new tables in it. So you could call this favorites DB, whatever you want. You just won't want to reuse the animals table. You can create a table called favorite foods. It's going to have a column called food, a column called score. I would even say you could throw in the ID if you want a column here if you want as well. For favorite songs, you're going to need to include the song, artist, and a score with the appropriate data types as well, and whether they can not be null or whether they're allowed to be null. And then the same thing for movies, which is going to have strings, booleans, integers, and a primary key set on it. And then you can try inserting some data into the database. Insert some of your favorite foods, insert some of your favorite songs, insert some of your favorite movies. We're going to be working on this for the next 20 minutes. If you have questions, let us know. We'd be more than happy to help you out. Good luck. All right, folks, still coming back. If you are still having issues connecting to MySQL, a lot of times going through the instructions again help. If you're still having trouble, you can we'll be happy to help you out. We'll definitely be taking some time during office hours to make sure everyone's machine is configured correctly, but we also want to make sure that you're able to sort of see a little bit of what's going on with SQL today. As well, we'll be talking about more SQL tomorrow. If you are having trouble with doing some of the exercises, I would say just take the exercises this afternoon and go through them again while we're watching the video as a way to catch up in that case. But we want to make sure that we are progressing through the content. So what we were tasked with inside of favorites DB unsolved SQL, we saw this SQL file that kind of started us out along the way. Now, drop database, if exists, favorites DB. We then have create database, favorite DB. How can we make it so all of the following code will use that new favorite DB?
Use favorite DB.
Use
Yep. So we're going to say use favorite DB. And that kind of switches whatever environment you're running into now using that database. Next, we've got a table called favorite foods. Let's go ahead and add some columns in here. The first one is a string column called food, which cannot contain null. Daniel, I believe you answered that last one, so go ahead and pick someone to go next.
Michael.
Food, bear care, not null.
Food, fair care.
Yeah, and I just put 30 inside it.
30 seems like a good amount. And that's just how many characters you have to work with. If you're working with really long names, maybe you're working with like some folk food that has a really long name, or maybe it's like any recipe that seems to be online where it's got someone's life story in the title somehow, then you could also put it on there. So next, we want to make a numeric column called score. So we start out with score. And Michael, let's have you finish this one out for us. What else do we put here?
I just put integer.
Mm-hmm.
And then I put 10.
And anything else?
Comma.
Yeah, we'll need a comma right here. We don't want one after here necessarily. You could, I think you can include it. I forget if SQL allows trailing commas or not. Some languages do, some languages don't. Now, this is fine. And this is what the exercise prompted you to do. What I would encourage you to do is whenever you make any titles or any tables, go ahead and include an ID column. And you can just copy paste this from 1 to 1. So ID integer auto underscore increment. Did I type 0 there instead of O? No, that's just how it looks on the font. Auto increment and then primary key, comma. Now, by default, in Visual Studio Code, it's going to assume that you're using Microsoft SQL, or sometimes called T-SQL or transaction SQL. This is fine most of the time, but there's going to be the occasional thing it doesn't syntax highlight correctly. Auto increment is one of those things. So if you see that, but you can either do this by installing something that specifically, or that is MySQL specific as a plugin, or you can do what I do, which is go, oh yeah, I know that one already. Cool. And then it'll pop in some of the other ones on here. Cool. So that works there. Michael, go ahead and pick someone to help us with our favorite songs category. And we'll just copy the ID over again.
I'll do Omar.
Omar. Next, we need a string column called song, which cannot contain null. What's that going to be?
You could do string column come song, so it'd be song bar char 30, not null.
30, not null. Excellent. What about for artist? What do we want to do, Omar?
You just same thing. Just change the title to artist.
And then we can have an integer column called score, which is already there. Awesome. And then we copy pasted the primary key. Another way that you can see primary key on here is you can, well, sometimes also see it listed at the bottom as primary key and then the one that it refers to. I forget if you need the parentheses or not. Usually I have syntax highlighting to help me with that. But you'll see it either way. I tend to just write it all on one line up at the top. So it's like, hey, this is the ID, it's the primary key. Why put that information somewhere else? Awesome. Omar, go ahead and pick someone to help us for the final favorite movies table.
I see Steven on my screen.
All right, so for movies, we can do the ID int auto increment primary key.
So we'll start out with the primary key. Yep. a lot of times people will add not null on there as well.
And then we'll have movie var character 30 not null.
Movie.
Var character 30 not null. And then 5_times Boolean. And then default parentheses false.
And I think you can actually just write default false on
Okay.
there with that sans parentheses. Next, what do we have? Basically a carbon copy of that one.
Yeah.
And then we put primary key up here. If we didn't do that up here, we could do it down here if you want to. You only need to do it in one place, but you can set something as the primary key after the fact in a separate command. It doesn't necessarily have to be on the same line. A lot of times you're going to see it on the same line because it's ID and people know to kind of expect that. Cool. Let's try it out, make sure that it works. So I'm going to copy all of this into my workbench. I'm going to say File, New Query tab, paste this in there, select the whole thing, execute it, and I'm going to refresh my schemas. And now I'm going to see a new database in here called Favorite DB. Let's go ahead and look at the different tables. I can see that I have favorite foods, favorite movies, and favorite songs. If I right click on it, I can actually see the table inspector, which will give me the opportunity to look at the columns in a little bit more detail, where I can say, hey, what's the name? What's the type? Can it be nullable? And then some other things on there as well. For example, the ID auto increments. You don't necessarily have to have an auto incrementing ID. You could just say, hey, they have to give this to me, and I'll make sure that they're unique and things like that. But most of the time we just auto increment it. We ask the database to handle that portion for us. Questions?
Is there a reason why the order that it goes in changes? So we have it as food, songs, movies, but when we run it, it comes out on the tables with movies in front of songs.
So what this is doing is just organizing it alphabetically.
Okay.
So the order is not particularly a big deal. It's just going to organize that, because as you have more tables, them being organized alphabetically will definitely help you find them. So the order doesn't matter. If it was easier for you, you could have changed the order and it'd be fine. They're not dependent on each other in any particular way like that. Right on. So
I have a quick question. So
yeah,
like
go for it.
when you're inserting, in the case with like auto incrementing ID, what do you put as that first like character?
So you leave it blank. You don't give it an ID. When it's auto incrementing, it takes care of that field for you. So you're never going to provide a value for that field.
So it'll just be food and score or song artist and score. Cool.
Yeah. Go ahead.
In my create table for favorite foods, it did not like integer, and I took out ID, and then it didn't like auto increment. Can't get rid of the red squiggly.
Yeah, on that guy, the auto increment, that's because, again, this is this editor right here. It's saying, hey, this is Microsoft SQL, which is the one that Microsoft makes, and Microsoft, the people that make Visual Studio Code, are like, you mean the one we make, right? And again, remember, MySQL is a dialect of SQL, which means it's going to be subtly different from other flavors of SQL. So it's auto increment is one of those flavor differences, you might say.
What did you click on to make that drop down box?
It just says choose SQL language on there. So if I click on this, it'll ask you to do that.
You're in VS Code. Okay.
Yeah.
Thanks.
So some of that and then it's just more generally SQL. If you can give it like MySQL, like by default, there's nothing on there. You can get that with a plugin, pretty easy if you want, but I kind of leave it off, A, because I don't use SQL that much outside of the workbench, and B, it's easy for me to explain this exact same thing to students. Because we see it in the same place. Awesome. So the next thing I want to do is I want to jump ahead a little bit, because what I'd like to do is I'd like to end this class with us not only have connected our workbench to MySQL, but know how we can connect Node itself to MySQL. How can we connect our JavaScript programs to MySQL and use them? So we're going to jump down to 06, ice cream with connection. We'll go back and we'll revisit some of these tomorrow to help us review stuff. I just want to jump ahead so that we can see this. We can see if you're having any issues connecting to it now rather than later, so that we can catch any issues, resolve those. So as we go through the rest of class, that won't be impeding your progress. So what are we going to do? We're going to start out with this database. This is a schema file, and it technically has a seed as well. When something has columns in it, it defines our structure with the tables and columns. We call that a schema file. When something has rows that it's inserting into that schema, we call it a seed file. Sometimes the two will go together. So this is a schema file and a seeds file kind of put together. Usually they'll just call it one or the other. So this is going to make a bunch of ice cream for, let's say, an ice cream shop. Let's say maybe it's Amy's Ice Cream here in town. And they have a bunch of products like vanilla, chocolate, and strawberry that have different flavors, prices, and quantities. So we're going to, again, open up our connection to the MySQL workbench. We're going to go ahead and make a new query tab. Up at the top, we create this drop database if it exists. We make a new one, we use it, we make this new table, we insert data into it. So we click this, it runs, and now I can refresh this and I'll see Ice Cream DB with a table called products. If I right click on it and select it, I'll see the 3 flavors that I inserted already. Awesome. So now there's data in this database. My next task is to make sure that I connect to it. And we're going to sort of break that up into 2 parts. Just connecting to the database, and then making sure that you can actually read information out of it. And that's going to be a combination of 06 and 07. So the first thing we want you to do is to make sure that it works with 06 or 07. In fact, let's just jump straight over to 07. It's the same seed file, so let's just jump into 07. So I'm going to right click, ice cream, read data, open in terminal. You'll also notice in here, there's 2 other files besides the seeds file. There's ice cream read data.js and a package.json. Inside of the package.json, we have a package called MySQL. MySQL is what's called a driver for the MySQL service. So this is what enables us in our JavaScript to talk to the MySQL server. So we're going to have an API that we use, the MySQL API here, that lets us talk specifically to our database server. And that's what's going to be inside this one right here. But to do that, we need to first run npm install so that we have that MySQL package. Again, inside of 07, ice cream read data, we're jumping a little bit ahead. We'll revisit some of the previous activities the next day. I just want to show you so that you have an opportunity to check if it works. Next, we've got ice cream read data. And what we do here is we create a connection the same way that we kind of did with the workbench where we had to enter all of the details. Then we connect to the database. And once we've connected, we can run a query. We can see here that the query is select star from products. And we have a callback function, which will give us the results. Now, if I try and run it as is, if I just say node ice cream read data.js, it's going to give me an error. It's going to say, hey, access denied for my user. And I'm going to go, okay. And then I'm going to come up, and the first thing I'm going to check is my connection. So the host is correct, it's localhost. That's my local machine. The port is 3306, that's the default for MySQL, and if it worked when connecting last time, it should be the same here. Our user is root. The database is correct with ice_creamdb, that's the same as our seed file. Oh, what's different here? The password. I didn't include my password here. Now my password happens to literally be DB password original, I know. And so I'm going to use this. Later we'll learn about using .env and environment variables so we can hide this information so we're not putting database passwords up on GitHub and things like that. So after I do that, I'm going to save it. I'm going to come back to my command line and I'm going to run it. And now you can see that I've console.logged out 3 objects in an array with 3 objects in it. The first is my row data. For my first row, I've got an ID of 1, a flavor of vanilla, a price of 2.5, and a quantity of 100. And then the same thing for chocolate and strawberry beneath it. This is, at a very simple level, how I can start getting data out of my database. We'll be looking in the future how we can run those other CRUD commands that we've been running, but you'll notice right here at the beginning that all of the stuff around the structure, everything about the columns and the tables and higher, we handle not in the JavaScript code. We're not using the JavaScript code to change the structure. We want our program to not change the structure. We want the program to use the structure that we put in place with this other file. So we have this file and then we run its contents in order to create the structures that we want in the MySQL server. And we can check that structure by opening up the SQL workbench and inspecting what's there. Again, this is something persistent. It's sticking around. If I shut off my computer and restart my computer and restart the SQL server, that data will still be there. And that's what we want in a database. That's one of the main things we want to have as we do this. Cool. So what I want y'all to do is just take the last 10 minutes in class. And if you're able to successfully connect your workbench, try and do this exercise. Again, it's going to be doing npm install, and then updating your password, and then running it. And if you can see this right here, you've done it correctly. All works out fine. If not, you're having some other kind of connection issue, let us know. We'd love to help you out and get those connection issue resolved. So we're going to go ahead and break into your different breakout rooms to give you a chance to work with each other on this. That'll also let us potentially work with multiple people if they're having similar issues. Office hours is going to be spent doing one-on-ones and then helping to troubleshoot any SQL issues. So tomorrow we can really hit the ground running with some of this stuff. Hopefully you enjoyed your intro to SQL today. We'll definitely be talking about it more as time goes on. We're going to backtrack a little bit, give you a little bit more practice with the SQL syntax, but we wanted to make sure that if there are any connection issues, we can resolve them today. All right, we're going to open up the breakout rooms at this point. If you need help, let us know. Good luck. What up?
I don't know what happened. Everybody left the breakout room, and I went to leave it too, and you ended up with me. Sorry.
What? Nah, we're just in the main session.
Okay. If you're not doing anything, I got a question because
Sure.
mine's not working.
For sure.
I'm getting a client does not support authentication protocol requested by server.
All right, that means that you installed it with the wrong authentication credentials.
Okay.
Yeah, so you're going to need to reinstall it. And if you look in the markdown file, I forget exactly where it is, but there's let me find it. It'll be on both of the guides either way. It's a MySQL server issue. Easiest way around is just to reinstall. And so let me share my screen. I'm sharing, you can see the documentation right here. So as you're going through, it's like yada, yada, yada. You want to do all this stuff. So server only, fantastic. MySQL 8. And then this section right here, authentication method. Likely what you did is you had this button checked when you need to have this button checked.
Okay.
So that's what that error is.
Use legacy authentication.
Mhm.
Okay. And I found that when I Googled, and I just had no idea what it meant.
Yeah. So that's like midway through the documentation. And that'll be on either the Mac or the PC guide. I think this one is on the Windows, but it'll be there for either one of them.
Okay.
You might be able, if you have the installer already, just to reconfigure it. But just running the installer again is probably the fastest way to resolve that issue.
Okay. I will jump on that.
Yeah, it's office hours at this point, y'all. So if you have questions, feel free to join the main session. Or let me make sure I write that at here. Feel free to join the main session if your group is not already receiving help from one of the TAs. There we go.
I did have one quick question for you.
Uh-huh.
Because it took me a while to get my SQL set up to where it was working. So it looks like it's connected. It gave me a connected as ID 21 when I ran it in Bash and VS Code. How do you pull up the little table that you had underneath where you were putting the information in the workbench?
Oh, for that. So if we go back to the workbench, whenever you run a select statement, it's going to pop that up for you. This is the result grid. It says, hey, what's the result of running that command, essentially? You can also get it by right-clicking on it, the table, and clicking select row top 1000, and it'll pull that up as well.
All right. Okay, yeah, there it is. Awesome. I just kind of missed out on that while I was trying to get it working.
No worries. We intentionally tried to not cover too much before we gave everyone a chance to sort of solve their issues while still giving you a taste of what's to come. Other questions?
So I got a message on mine saying client does not support authentication protocol requested by server. Consider upgrading MySQL client.
Cool. So what you're going to do is in the installer section, you're going to arrive at a portion on here called authentication method. So you're going to have to reinstall it. You need to make sure that you have this one selected. By default, it'll say use strong password for authentication recommended. We don't want that one. We want to use the legacy authentication method because of the way that we're connecting to it.
Yeah, I just went through this process and it worked for me. Like uninstalling and reinstalling. So Eric, we're talking about using MySQL just to like manipulate and manage the databases, but you easily take those same skills and use them for like data analysis as well. Yeah.
Hmm. So it's just working with data.
Yeah.
So you could use this to build reports or charts or other things as well. We're going to give you kind of like enough to kind of get you going. We're not going to dive deep into like, hey, here's how you analyze this data or stuff like that. But it's enough to get you started in like taking data from users and using the data given to you by users and stuff like that. But there's a lot of cool resources out there for data analytics and how to do that kind of stuff. JavaScript has a bunch. The Python community has a lot of stuff around that kind of thing. Most of the articles that you probably look up are going to be like, we're going to do this using Python. So you might have to add in like JavaScript unless you want to learn Python to do that kind of stuff as well. But there's plenty of JavaScript libraries out there, just that it's not as much the default as Python is for working with lots of data and trying to find trends and things like that. But like you could do that in any language. It's just the Python community tends to be a little bit more like scientific computing and data computing focused versus JavaScript is very, very, very web.
Do you think that it's better to start with one or the other?
I think either one's fine. I like JavaScript as a base because you can do things in a browser, and so you can get a site or something going on in front of a person really quick, and you don't have to get them to like download something and install it on their machine. You just point them at a link and you're like, this does a thing. Which is one of the reasons I like it. Not that you couldn't with Python, but I like JavaScript. Like I don't know Python super well because I know JavaScript, so I'm already good to go on a lot of the same things.
Where's my motherfucking chirp wheel?
Hmm?
Oh, sorry, that's put us on mute. I got a chirp wheel, and it's supposed to come today. So.
Okay. What's a chirp wheel?
It's like the next generation foam roller. They come in different sizes, and it's just like